specified a simple regression model that is the most simplest econometric model which we can think of. And after specification, we discussed how to estimate it. Okay, so that discussion is not complete. I discussed there is one procedure. There are many procedures in fact, like least square procedures of several variety, which you'll be learning afterwards. And another variety, completely different variety, is maximum likelihood estimators. So the least square estimators and maximum likelihood estimators are broadly two sets of methodology which are used to estimate an econometric model. Okay, so among the least square procedures, the simplest one is ordinary least square procedure, which we are discussing. And in that, the procedure I explained to you, we are trying to basically minimize the sum of squares of deviations. These deviations are nothing but deviation of actual value from the estimated value of the econometric model. So these sum of squares of deviations we are minimizing, and applying that principle, we are trying to estimate what are the best possible figures or numbers for beta 0 and beta 1. Okay, so let us put these estimated values of beta 0 and beta 1 as beta 0 hat and beta 1 hat. Okay, let me open my PPT now. Okay, before I start, if anybody had doubt on what we had discussed until now, you can ask me before I proceed further.
Sir?
Yes.
Sir, how do we derive that formula beta hat is equal with n summation of xy, yy minus summation of...
Wait, let me open, where is that? Okay, which formula you had difficulty?
Sir, you told that last formula beta hat is equal with n summation of x. Yes, sir, beta. Yes, sir.
Which one? First one, you tell me which line? Third line, fourth line?
Sir,
Where
the
you had
third line.
difficulty? Third line.
Yes, sir.
Have you got these two normal equations? You understood these two normal equations?
Yes, sir. Yes, sir.
Okay.
Yes, sir. That much I got. Yes.
They've got, right? So
Yes,
is it that difficult from here to basically go to the next step?
Yes, sir. Sir, it's trying to apply that matrix formula.
No, matrix formula or whatever you do. Is it that difficult? I think you are Soumyaranjan, who is asking?
Yes, I'm Rasmuranjan Das.
Rasmuranjan, okay. So for a student like you, I'll ask you try it yourself. I can do that. That's a matter of 5 minutes. But for student like you should do on your own. You refer to Gujarati. This is there in book. Otherwise, I would have spent some time. So for a student who is not good in quant, of course, I would have helped that. But you have scored good marks in math, so I understand your quant is good. So you try on your own first, okay? So when you try on your own, they say, no, I think you are from Odisha, right? In Odisha, in Odia, we say, what we say that? Uh, Basically neighbor's curry, either the curry you prepare yourself, that is one thing. Second is you get some curry from your neighbor. Okay, getting from neighbor is easy, but then if you prepare yourself, that gives you more confidence. Anytime you can prepare. And secondly, you will prepare as per your test. Neighbor prepares as per their test. Okay, so it is not difficult. You try Gujarati or all any which econometrics book you are referring to?
Sir, that Gujarati book only.
Gujarati, it is there in the appendix. Okay, so you see that depending on which edition you are using. If it is the latest edition, I don't know. The edition which I am using is sometime, I think 2005 or something. In that edition, in the appendix, it is there. So you try once, in case you are finding still difficult, I'll do that. See, basically how I'll give some hint. It is not that difficult. See, this C star I'm telling C mean, no? How C mean will appear? C mean, oh, okay, no, let me put it as this as Y, this as X. This one I have not changed it. Okay, so basically your beta 0 is your y mean minus beta 1 hat x mean. Okay, so y mean is what? Y mean is summation y over n minus beta 1 hat summation xi by n, right? So from here you are getting those means. So you see these are there, summation yi somewhere here, summation xi somewhere here, right? So from there you will get it. You try, okay? Right.
Oh, okay.
Now, okay, so okay, what we discussed is your principle of minimizing sum of squares of error. Applying calculus, we got these two normal equations. From these normal equations, we got these formulas for beta 1 and beta 0. Okay, I think this deviation from that I'll come later, but up to this, other than derivation, I hope the principle all of you might have understood. Okay, so this is what I was telling, depending on the values of beta 0 and beta 1, you have different straight lines, like line 1, line 2, line 3. And that particular line we choose, which is best explaining the pattern of relationship between y and xi, where you are minimizing the sum of squares. Okay. Now in graph, how it looks like, okay, or how you get those numbers. In reality, assume this is your income is your x variable, right? And consumption is your y variable. Dependent variable is y variable. Explanatory variable is your x variable. Okay. So in reality, you may have data like this corresponding to, say, income 10, somebody's consumption expenditure can be 5, corresponding to this individual also having income 10, or consumption may be 7, another individual's consumption expenditure may be 9. So with same income value of 10, you have three possibilities of consumption expenditure from your sample. Assume there are 10 individuals whose data you have collected. Similarly, with income of 15, there is one individual whose consumption expenditure is 10, another individual whose consumption expenditure is 7, third 11, and fourth 12. Okay. Then there are some individuals with same income of 20. For them, similarly, you see there is a variation in their income. Okay. Now, if I plot those figures in my graph here, okay, my y-axis represents consumption, x-axis represents income, then you have these red dots. Okay, these red dots are basically the observation. Corresponding to 10, we have somebody having income 5, somebody having income 7, sorry, somebody having consumption expenditure 5, somebody having consumption expenditure 7, and a third person consumption expenditure 9. And corresponding to income of 15, you have 4 individuals, their consumption expenditure is given by those red dots here. Okay, and 1 is here. And corresponding to income of 20, again you have 3 individuals here, 3 different consumption expenditure. Okay, now I can fit the line blue line, I can also fit the red line. Like that, you have many possibilities, many lines you can fit. Okay, so if I fit the blue line, then my beta 0 is 1, my beta 1 is 0.6. That is for this line, this blue line. Okay, if I fit the red line, my beta 0 is minus 3.2 and my beta 1 is 0.88. So depending on the value of beta 0, beta 1, you have here two possible lines which you can fit to explain the pattern of relationship between your consumption and income relationship, right? Now, which one is better? Okay, how to know which one is better? For that, we'll apply the summation of ui square, minimizing that, and from that principle, we'll get the values of beta 0 and beta 1, which are the best. Okay, which perhaps explains the relation between those consumption and income as given in the scatter plot best possible way. Okay, here I have information for per capita Consumption, this is real data for India. Per capita consumption is given by PCC and per capita income is given by PCI. Okay. So using this information Y and X and applying this formula that beta 0 is equal to Y bar minus beta 1 X bar, and beta 1 is equal to n summation yi xi minus summation yi summation xi whole divided by n summation yi square minus summation yi whole square. Okay, so applying this formula, what I got beta 0 to be this much and beta 1 to be this much. Okay, see here, beta 0, this is per capita consumption, per capita income. So can you expect beta 0 to be negative? In our economic theory, can beta 0 be negative? What is beta 0? Beta 0 actually subsistence level of consumption, isn't it? All of you are hearing me?
Yes,
Hello?
sir.
Yes, sir.
Yeah.
Yes, sir.
So if your model is CI is equal to A plus B YI, this is your C0, which we call subsistence level of consumption. So according to theory, subsistence level of consumption cannot be 0, isn't it? But now
Yes.
here you got it as 0. I mean, it's as negative, not 0, negative. Okay. So I told you your beta 0 estimation will be meaningful only if you have adequate observations of the explanatory variable which are close to 0. See here, your all your per capita income figures are more than 45,000, isn't it? 45,000, 48,000 up to 94,000. So these are very different from 0. Okay, had I had some number in mind or figure, say this is okay, this could have been say 0.1, if this could have been 0.02, or this could have been minus 0.03, like that. Say out of 20 odd figure or 15 odd figure which I have here, out of that, if 7-8 numbers were around 0, then perhaps you will not get this as negative, you will get some meaningful number, right? So this point which I made earlier in when discussing about the intercept and slope coefficient, etc. At that time, I told you, unless you have adequate number of observations of the explanatory variable close to 0, then intercept may not be meaningful for you. And you saw it here. Okay. So that is one thing. Then of course, as we go on, I'll tell you another thing regarding the number of observations here. Here the number of observations is only 15, and this is less than what minimum we require for getting meaningful sound or robust estimates for beta 0 and beta 1. Okay, so that is will come little later. So now if you are asked to estimate a model, what is that, an econometric model using some data. Okay, like here we have per capita income and per capita consumption expenditure. You can take demand for good and the prices. I mean, given the different prices, how many units of goods, different units of a particular good individuals will buy. You can collect the information and then similarly apply the formula for beta 0, apply the formula for beta 1, and you can get the estimates like I got it here. Okay. Now this consumption income relation, these figures which I have in this table, if I plot in a scatter plot, they will look like this. Okay. So if that straight line which we estimated, that line may be something like this, where slope will be 0.66 and intercept will be minus 1200, close to 12, minus 1200. Okay. Now the MPC is greater than 0 and less than 1. So this is in conformity with Keynesian consumption function, where we are expecting MPC to be greater than 0 and less than 1. So that hypothesis appears to be correct. The Keynes hypothesis that MPC is greater than 0 and less than 1, that is proven here in using this data set. Okay. So you should be happy. Yes, Keynes is right. In reality also, it is not only in theory, in reality also is right if I'm using this sample. Okay. Now, one issue which I discussed earlier is about a mathematical model. The shortcoming is you may like this example here. This is a abstract example. Okay, this is not a real thing, just some hypothetical number I have taken. So here you may have three individuals with same income 10, but their consumption expenditures are different. You have four individuals with income of 15, their consumption expenditure are different from each other. Similarly for individuals with income of 20, right? And the mathematical model had this shortcoming of taking this variability into account. Okay, so this one, when I'm having a model like this where I try to estimate the relation between consumption and income, this doesn't appear to be you know basically related to that, because you have just one individual with a particular level of income. You don't have many individuals with same level of income in this example. Okay, but if I have a, this is again real data, I have taken saving rate for various years. I think maybe 1950s to maybe 2012 13. Okay, for that period I have used the saving rate. Saving rate, of course, as you national income accounting already might have learned earlier in the first semester macroeconomics. So you know what is saving rate. Saving rate is the amount of saving over GDP, that we call saving rate. Okay, so it's basically ratio of saving to deposit in economy, sorry, to GDP in an economy. Okay, so it is not rate of growth, it is saving rate. Saving rate is the ratio between the savings and GDP, that is plotted in the x-axis. You can see that our saving rates varies from close to 9% up to maybe 38% in our data set, and your income economic growth is given in y-axis. So here in the x-axis I have saving rate. Okay, and in y-axis I have economic growth. Economic growth for India. Okay, and you have plotted them in a scatter plot. Those will look like these red dots what you have on your screen. And if I try to estimate that relationship, estimating beta 0 beta 1, then I get this yellow line which you have on your screen, which also shows that there is a positive relation between saving rate and growth, that perhaps you might have learned in your growth theory. I think growth theory you have maybe limited understanding up to now. Have you read neoclassical growth theory, solo model, in your BA level? Any one of you studied solo model in your BA level? Solo model of growth? No.
No, sir.
Okay. So
Yes, sir.
Haradomar, somebody has studied? Who has studied? Tell me.
Sir, Akanksha.
Akanksha, good. So what are the major main findings of solo model, ma?
Sir, I remember that the long run growth it depends on the capital accumulation, labor
Mhm.
and population growth, sir.
Good, good. At least something important you have remembered. And do you remember in the solo model there is a stationary state, there is a steady state?
Yes, sir, I remember, sir, but not
I don't
fully,
know
sir. The
exactly. Okay,
technological
okay.
progress, sir. Yes,
No
sir.
problem, no problem. We'll be learning these things in growth theory in your third semester. I'll be teaching you growth theories. So, of course, we'll start with basic ideas of Smith, Ricardo, then Harold Domar, that very briefly in the first module. Then we'll discuss about neoclassical models, which will be both 1 minute. There is a call from BC Secretary. Hello. Good morning. Please tell me. Okay. Okay, okay. First of April. Okay, okay, okay. Thank you. I'll do that. Yeah, thank you. Hello. Yes. Where were we? Okay. Yeah, I'll not discuss much about growth, but it is one interesting thing which you'll be knowing. See, I'll tell you, economics is such an interesting subject. Once you realize how to relate with reality, then you'll feel very excited about it. Okay, so of course, solo model I'm not discussing now because many of you will not understanding, except those you have read earlier. So in solo model, what the two phases are there. First, there is a stationary phase. I mean, it's a transition phase. In the transition phase, as you can keep on increasing your per capita capital, your economic growth will keep on increasing. But once per capita capital reaches at a particular level, then which we can call some threshold level, after that, any further addition to per capita capital will not lead to further economic growth. We call it steady state. Okay, so saving rate can generate growth, higher and higher growth, until, because of course your capital formation, your capital expenditure has to come from capital expenditure in economics means accumulation of machines, factories, etc., has to be financed, right? So somebody has to save, so that this saving will come to the entrepreneur or the household to invest, right? So now if you keep on increasing saving rate until it helps to increase per capita capital, until that level, steady state level, there will be increase in economic growth. Okay, so India being an economic, sorry, developing country or poor country, we can consider it is still in that transitory phase, that transition phase. Okay, where increase in per capita capital leading to increase in economic growth. Okay, once you reach a rich country standard where per capita capital reaches that threshold level, then your economy starts growing at a constant rate. Okay, it's not that it stops growing, it will growing at a constant rate like 2% or 4%. Okay, so it will be growing at that rate, but per capita growth will become stagnant. Per capita economic growth will become stagnant. But India being a developing economy, you can see from here that now with the increase in saving rate, which perhaps leading to increase in per capita capital, our growth rate is increasing, becoming higher and higher. Okay, so by learning econometrics, these things become very exciting for you. What you learn in theory, you apply that to examine the relationship in reality using Indian data, American data, world data. So that helps you become technically more correct. See, without econometrics also you could have plotted those dots here. Okay, anyway in statistics you have learned how to make a graph, so that way this scatter plot you could have drawn. But then learning econometrics, and from this scatter plot it appears roughly there is a positive relation, but scatter plot will not give you pakka information. It is a tentative conclusion you can infer. But once you have this econometrics, learn econometrics, you can fit this curve. Okay, there are many things to learn in econometrics. Now whatever we are doing, it is still statistics, mathematics. After we discuss in detail about you'll start learning some additional things in econometrics, which you didn't learn in stat and math. So this straight line now definitely suggesting there is a positive relation, but whether this positive relation is statistically significant or not significant, that we'll discuss as we go on. Okay, yes. So here I'll now take you to a new issue. See, until now what we are discussing how to construct or specify an econometric model and how to apply OLS to estimate the coefficients of the model like beta 0 and beta 1. All of you clear until now? If anybody is having doubt, please ask me. Okay, I'm proceeding. See here, the beta 0, beta 1, which we estimated using OLS, okay, we are discussing it theoretically until now. There is a theoretical model like a Keynesian consumption function, or theoretical model like law of demand, and in that theoretical model, beta 0, beta 1 are the coefficients. Okay, now when we discuss the things in general, that means this Keynesian function which we are talking about, that is applicable for India, that is applicable for America, that is applicable for Sri Lanka, that is applicable in 1950, that is applicable in 1960, that is applicable in 2021. These are universal things, general things. Okay. So when we discuss this econometric model for a general case, okay, you know that in statistics this is for the population, population sample, right? So that is for the population, where the population you have used for collecting data. Okay. Now, the way we discussed how to estimate beta 0, beta 1, okay, that is for the population, right? So we call them as population parameters, beta 0 and beta 1, which are the coefficients for the model, which is used in general for the population. We call them as population parameters. Okay. There are, in reality, as you know, I told you earlier, econometrics is a non-experimental science, right? Here you cannot generate your observations. Already observations are there. You can use that only. It is non-experimental. You cannot experiment and create data on consumption, expenditure, income, etc. Already people are living. They have their information on consumption, expenditure. They have their information on income. You can only use those information. That's how it is a non-experimental science. That is one thing. Secondly, there is no researcher who can collect income and consumption expenditure for all people who lived in the world. Impossible, right? Maximum what you can do, depending how much efforts, I mean, how much money you can spend and how much time you can spend, you can collect data for a set of individuals. Maybe 100, maybe 200, maybe thousands, maybe at the maximum lakhs if it is an institution. Okay. So collecting information for every individual on their income, on their consumption expenditure is not at all possible, even for the same country, for same India, let us say. Okay. Then what is the solution? The solution in statistics you have learned, when you will not able to collect data for all the units in your population, we can use sample design. We can develop a sample scientifically. You might have learned many ways of, having a sample design, whether it is a cluster sample, stratified sample, various random samples, which or whatever learned in your statistics. You can use your best information drawing from your, sample design topics, and then perhaps construct a best possible sample on which you will collect data. Okay. So your population may be, several billion, but then you are not able to collect data for all the several billion. You may be collecting data, maybe say for 100, for 200, for 500, or 5 lakh, something, some number. And actually what you do, you estimate this relationship for the for the sample only, not for the population. Okay. So when these examples which I gave you a little earlier, these are actually examples for the sample. Like as I said, I have collected Indian data from say 1950s to maybe 2011-12. This doesn't include 1940 or 1939 or 1927 or 1911. Okay. Or also it doesn't include the future, like say 2025 or 2036. Okay. It is only a segment, small segment out of the large number of years of data which possibly could have been drawn. Data is not there, of course, on Indian data on savings and economic growth you will not get for 1868. Generally for India, our most of your economic data is available after 1950-51. Okay. So when I don't have data, what I can do, I can basically limit myself to a sample. Okay, that is the best possible, second best way. And then from that sample, I will estimate the relation. Okay, so when I'm estimating for this sample, maybe I will denoting my coefficients differently. I can say yi is equal to beta 0 plus beta 1 xi plus ui. Okay, so in general, actually, this model is yi is equal to beta 0 plus beta 1 xi plus ui. This is in general. And correspondingly, I said beta 0, beta 1 is are population parameters. And for the sample, we'll call them as sample estimates. Remember these names: population parameters, sample estimates. These are two sets of coefficients. Population parameters are the coefficients for the population, the model which is constructed for the population, and sample estimates are the coefficients which are basically based on the sample. So in reality, what you estimate, you are actually estimating sample estimates. Okay, like here, I have estimated these numbers as I said. Let me clean these here. Yeah. So these are the numbers which I got. So this is a sample estimate. Similarly, this is a sample estimate. Okay. So in economics, what we are doing, we are basically using the sample, and from sample, we have estimated the relation which we call sample estimates. But as a student of economics, your conclusions should not be limited to a sample, because the conclusions drawn for different samples can be different. Okay, say assume this is my sample 1. This is my sample 1. The sample means information on x and y for these many years. I'll call it sample 1. Okay, for sample 1, beta 1, b1, I got 0.66. Had I chosen sample b or sample 2, okay, say I could have estimated this relation from for 1997 up to say 2004-5. That could have been my second sample. Then maybe this estimate is say 0.51. Okay, I may have a sample 3 for which maybe the relation is 0.89. I may have a sample 4 where the relation can be this sample coefficient, sample estimate for MPC could have been say 1.01. That is contrary to theory, right? But it is a possibility, right? Here like beta 0, B0 you got as a negative number. This is a possibility, right? So the point which I'm trying to make, this is now very, very critical for you to understand what I'm telling. This is very critical to migrate from statistics to econometrics. Okay. So I'm repeating, I got this number of 0.66 because I have chosen a particular sample here. That sample, maybe I'm denoting a sample 1. Had I chosen sample 2, my estimate for beta 1 could have been 0.51. Had I chosen sample 3, I mean some number I'm telling, some number which I don't know. I'm telling it may be 0.51. Had I chosen sample 3, it could have been some other number like 0.81, 89. Had I chosen sample 4, it could have been 1.01. Okay. So the important point which I'm trying to make is the estimate for B1 which you get, that depends on which sample you have chosen, right? So when you have different numbers or estimates you are getting for B1, depending on what specific sample you have chosen, how to draw conclusion for general value of beta 1. See, beta 1 value is valid for population as a whole. But as we cannot get the information for the population, for the entire units which are part of the population, so never in reality we can know what is actual value of beta 1. Are you understanding? Because I cannot get data PCC and PCI for everybody, so I cannot estimate the relation here. Oh, I have removed that. Okay, I can I can never estimate the model. I can never estimate the model yi is equal to beta 0 plus beta 1 xi plus ui. This model I can never estimate because I'll never have this information on beta 0, beta 1 with me. So these numbers I can never observe. I don't know. I mean, I can never assure myself with 100% confident that beta 1 is 0.6. This is a very important critical point I'm telling you. So there is lots of imprecision, there is lots of uncertainty about what is the value of beta 1. Like Akhilesh at the beginning was asking whether you can come back to campus in third semester. That is very, very uncertain to predict today. Somebody say you can have 7%, 70% probability, somebody say 90% probability, somebody say 0.1 probability. So we have not, nobody can with authority guarantee that you can come back on this date, that date, given the type of uncertainties as other things which are involved. So similarly here, beta 0, beta 1, nobody can see what is that value. Nobody can verify what is that number because you don't have information for the entire population. So then what is the second best thing we can do? We can estimate B1, and if we know the distribution, the statistical distribution of B1, depending on the properties of that distribution, characteristic of that distribution, we can say whether beta 1 is certain value or not with some probability. I'm repeating again. This again I'm telling, it is very, very critical. All of you understand what I'm trying to tell. I'm telling I have a sample like here. In this sample, I can estimate 0.66. Okay. And never I can claim, guarantee with certainty that given this value, what is the value of beta 1? Is it 0.6? Is it 0.9? Is it 0.1? I can never say with guarantee or with 100% confidence. What I can say, given this value of B1 as 0.66, and given that it is part of a random distribution. Why part of random distribution? This is again critical to understand. I'm sure even those studied econometrics, they will not be clear on this. Of course, I have given enough hint. I think somebody can pick up. Let me check. I think Akanksha, you studied econometrics, isn't it, earlier?
Yes, sir.
Can you tell me what I'm referring to? There is a random distribution of B1.
So the population consists of several samples, sir. So the B1 cannot we can tell the B1 based on the one sample estimator, sir.
I didn't understand.
So we take the population, and the population consists of several samples, sir.
Hmm.
So sir, the from the sample estimator B1, that we take that B1 is equal 0.66, so that
Hmm.
the sample estimator is based on only from one sample, sir. So
Hmm.
there are so we cannot tell the value of the population parameter beta 1 from one sample, sir.
Correct, correct. So then what is the next thing to do? Because we have to tell something about beta 1, right?
Yes, sir.
So how to
So,
migrate from here? How to migrate from 0.66 to value of beta 1?
Sir, I think we can say the value of beta 1 in some probability that the beta 1 can be that, sir.
So where
In
that
some,
probability coming from?
sir,
No, no,
I,
don't worry. See, even if you don't answer, don't feel embarrassed. I just want to ensure how many of you understood. So accordingly, I'll, pace my lecture. Anybody else, have you understood how to migrate from beta 1, B1 to beta 1? Those who had econometrics earlier, who else had econometrics earlier other than Ravensa University? In Kerala, some universities you had econometrics. Any one of
Yes,
you?
sir.
Okay, Abhirami, can you tell me how to migrate from B1 to beta 1? Basically, I want to
Uh,
understand how much you know. That's why I'm asking. Yeah.
Sir, I'm not sure, but is it through the we look on to the properties of the estimator and the estimator with the satisfying all the properties we take as the value,
What
sir.
properties, ma? Properties,
Sir,
where those properties coming
unbiased,
from? Hmm?
sir, properties like unbiasedness, least variance, efficiency, and the one with the satisfying the condition of blue.
See why there is a concept of unbiasedness coming here. No, no, what we're telling is answer is correct. I want to know whether you understand this. Where the concept of unbiasedness coming here? We have one number 0.66, right?
Yes, sir.
So where the unbiasedness coming here?
Um,
How we relate the properties of unbiasedness to 0.66?
so unbiasedness in the sense, the um actual value and the expected value should be equal, but I cannot explain how it comes.
Okay, okay, no issue. Any other student who had studied econometrics and know about this?
Sir,
Akhilesh, tell me.
I had not studied econometrics,
Hmm.
but I think can we use interval estimation for this?
No, why interval estimation? Where it is coming from? You have just a
Sir,
B1, right? Tell me.
okay, sir. This
Hmm.
is just sample statistics. While
Hmm.
we are making predictions about these population parameters,
Hmm.
we can say that population
There are
these
some
two intervals
there's some
with
problem in
certain
your communication. Akhilesh, there is some problem in the communication. I could not hear you clearly. Please repeat. I think he
Sir,
has.
can you
Yeah,
hear
you.
me?
Yeah, now I can hear. Now I can hear. Yes.
Okay, sir. We have the sample statistics here, and
Hmm.
we can say that in the this population parameter, the original value will be varying between a certain interval with certain probability. Like while we are estimating the interval estimation, we will say that we are 95% or 90% confidence
No,
that the
no.
population
See,
parameter.
Akhilesh, let us go step by step. I have a B1 number which is 0.66, right? That much
Yes, sir.
I know now. That much I know. I have a number B1 which is 0.66. Okay. So from here, how I'll move to beta 1?
Mhm. So using this as the point estimate for
Hmm.
the proper population parameter.
So I can say beta 1 is equal to 0.66.
No, sir, we cannot
Ah,
say that.
then,
But
okay,
we can
okay,
say that.
okay. Let me explain then. See here, there is
Okay.
Sir,
one catch. Yes, who is coming now?
sir, is it that the population follows a normal distribution and our sample is also following a normal distribution and we are seeing the distance between them and then predicting how close it is?
Yeah, actually, many of you you are giving an answer which is correct, but that doesn't assure me that you have understood. So that's why I'm repeating this question. See, basically, see this. You said normal distribution of zero, B1. How I just got a number 66, right? So where the normal distribution coming from? Your answer is right, but then I want to be convinced that you know this. That's why
Sir,
I'm
it's
asking.
based on the sample size, sir.
So where the sample is coming from? Say my sample size is 15 here. Okay, right? I have
Yes,
said
sir. Yes, sir.
2004-5 or 2019-20. So it is I think 16 observations I have. My sample size is 16, right? So based on
Yes,
that,
sir.
then move further. You have B1 as 0.66. Sample size is 16. Then
Sir, the sample size greater than 30 is on normal distribution, sir,
you
actually.
are telling something unrelated here. I see. That's why I know many of you when you are studying a subject, you are not going deeper into it. Okay, teacher is telling something, you have read in book something, you just store it in your mind, and you are trying to reproduce that. Your understanding is not clear, and even if you understood also, I don't know, you are not able to express yourself. Okay, so on both account you need to improve. My all these spending 10 minutes on this and interacting with you so that I get the answer from you is basically to do that your understanding has to be clear. Even if your understanding is clear, you are not able to speak, express that, you need to improve on your expression. Okay, so now what I understood out of interacting with 5 6 of you who are some sort of best in the class is either you have not understood, or if you have understood, you are not able to express. So that way, you need to work out to improve this. Okay. Now let me spend some time to explain this. As rightly Pragya told, there is a distribution here, but where that distribution is coming from? For that, I had given a hint, which of course Akhilesh was catching, but then he was not able to explaining adequately. So let me, what I'll do now, I'll insert a new slide here. Okay, let us do this. As I told you earlier, I got my B1 as 0.66. Okay, this is for my sample, let me say S1. So accordingly, I'm writing it as B11. Had I chosen sample S2, my B1 could have been what? How much I said? Some number I given earlier. So I have removed that. Okay, any number I can put. So maybe 0.59. So this is my B1, 2. Had I chosen sample 3, my B1 could have been say 0.87. This is my B1, 3. Had I chosen sample 4, my B1 could have been 1.02. This is my B1, 4. Like that, I could have chosen any of these samples, say sample N now, sample Sn. For Sn, I'll get B1n as some number like say 0.45. Okay. So what you see here, there was a possibility of picking n number of samples. Out of those n possibilities, I have chosen a particular one. So I got a particular value for B1 hat. Okay. Now, with some probability, I have chosen S1. Let me put that probability as P1. With some probability, I could have chosen sample 2. Let me put as P2. With some probability, I could have chosen 3. Let me put as P3. Some probability, I could have chosen sample 4. I could have got P4. Similarly, Pn. So now you can see here, this is a distribution of beta 1. Beta 1 can be, sorry, B1. B1 can be B11, B1 can be B12, B1 can be B13, B1 can be B14, B1 can be B11, B1n. And there is a probability associated with that, right? So if I give a new one, okay. If I plot these B1 values here in x-axis, so perhaps we can have some number beginning from say 0.2, possibly to maybe 1.1. So we had some number like say 0.66. This with probability P1. Let me put as this is the probability P1. Some number 0.59 is 0.66. 0.59 say here with some probability maybe P2. Okay. Then 1.01 with some probability maybe P4 I think I had. Okay. So you can see here for different values, different possible values of B11, there is a probability distribution. If that distribution is normal, you have some comfort. That is what I think Pragya was telling, if you have a normal distribution. But what normal distribution? Now you understood, Pragya? This distribution is the distribution of B1. Because B1 is a random number. It is a stochastic number. Why it is a random number? Because the probability with which you pick up sample 1 is random. Okay. This distribution can take any shape, of course. This distribution can be skewed like this, or this distribution can be skewed this way, or it can be normal also. I am not drawing a proper normal distribution. All of you know it's a inverted bell shape. I mean a bell shape curve. Okay, it should be symmetric both sides. So it could be any distribution. Okay, but of course, if it is a normal distribution, you have some comfort, but I'll come to that point later. If it is a normal distribution, you have some comfort. Okay, what comfort you have, I'll come later. But now you understood that this B1 follows a random distribution. A particular B1 you will get depending on the particular sample which you will pick up, and this particular sample you will pick up with some probability. That's how there is a probability distribution associated with the value of B1 which actually you get. Whether I get 0.66 or I get 0.59 or I get 1.01, okay, everything is associated with a probability. And this distribution, this probability distribution is a random distribution for B1. All of you understood now why there is a random distribution here? Then if this random distribution had certain properties, okay, then you will be lucky and you can say something about beta 1. So first point you remember, this is a distribution, probability distribution. Beta 1 has a distribution. Why it is having a distribution? Because beta 1 depends on a particular sample. You could have chosen any sample with some probability. So in reality, that probability is there. You have chosen one particular one. So imagine theoretically there is a probability that any sample could have been chosen with some probability. So once I know this probability and if probability distribution, and if this probability distribution has certain features which are suitable for our conclusion, then we will able to make some conclusion about beta 1. If not, if those properties are not there, then I will not say anything. I cannot say anything about beta 1. I can only estimate for a sample. I can tell that for my sample, B1 is 0.66. But in general, whether MPC is greater than 0, less than 1, I cannot say anything. Provided, unless your probability distribution of B1 follows certain, possesses certain properties. Okay. So first, these probability distribution has some properties which are suitable, helpful for us to draw conclusion about the beta 1. Second thing, even if the properties are helpful for you, still you cannot say with 100% precision that beta 1 is this number. At the maximum, you can say this with certain probability, that if everything is fine about the distribution, which we will be talking little while after or maybe next class, I can maximum say that with 95% probability or with 90% probability or with 99% probability, beta 1 is this. Okay. So this is, you should be very, very cautious as an econometrician. Some fools who don't know much about econometrics, the fundamentals of econometrics, because nowadays statistical software is available, data is available, they just run a model and with 100% confidence, fools have more confidence than the knowledgeable people. So they will say, this is this. Say, monetary policy is working for India, tax policy is working for India, this is that. With so much confidence they talk about. Okay. But I, as my students of econometrics, want you to remember this point, how things are uncertain in the econometric model. Okay. So we'll go step by step. So a couple of things which about the simple econometric model estimation, what I discussed only are here. We will consider beta 0, beta 1 as estimates of, we will consider B0, B1 as estimates of beta 0, beta 1 respectively by applying some estimation procedure. Basically, we'll estimate B0, B1 from our sample as sample estimates. Then using these sample estimates, provided they have certain properties, we can talk something about the beta 0 and beta 1. So that way, B0 will be an estimator for beta 0, B1 will be an estimator for beta 1, provided certain properties which we'll be discussing holds. Using B0 and B1, we can obtain estimated values of the dependent variable here is Ci, but general Yi, and the difference between the observed and estimated value also we can calculate. So once we calculate, A is coming here, it is B0, it's B1. Once I know what is B0, once I know what is B1 for my sample, I can get EI. This for my sample I can get. You can see, if you remember, in my earlier example, I had my A0 as say minus 1197 something, right? And B1 as 0.66. Okay, so my UI will be my actual consumption expenditure CI minus becomes plus, and this is minus this much YI in that model. So you know the value of CI already, you know the value of YI already. Use this number and you can calculate what is UI. So you see, if I go back, say in this example, I have my PCI, I have my PCC. If I get these estimates, then my error term UI will be, this was the dependent variable, right? Yeah. So PCC, say in this example, say this is 29,000 something. So it will be say 29,646 minus this amount. So this will become plus 1197.7 minus 0.66 PCI. So PCI value is how much here? 45,611. So whatever number I'll get here, that will be my U1 for the first observation. Say this some number, say if it is 10,000. So then my U1 is 10,000. After whatever I get from here, assuming to be 10,000, so I'm telling. So similarly, I'll get a number for this pair, so that will my U2. I'll get for this pair, that will my U3, and up to here will be my U16. This way, my error terms I can calculate after I know what is the value of B0 and B1. Okay, I think some days, in one class, I think one of you are asking how to get these UI. Now you see how we'll get these UIs. Okay. Then this is what I told you a little earlier, that different values of B0, B1 will generate different values of beta 0, beta 1. Okay. Depending on the values of B0, B1, we'll make conclusion about beta 0 and beta 1. Okay. An ideal estimator of the beta 1, beta 0 will generate a set of EIs. These EIs, which EIs are nothing but U's. Okay. Sorry. This is all what I discussed only, so no need to. Okay, I think this is this topic is over. So what I'll do, I'll now give you a break. Okay, break for 5 minutes. I'm also a little tired. I'll have some water. So then after 5 minutes, we'll resume. It is 12:39 in my watch. So 12:44 will resume. Okay, bye for a minute for the moment.